Okay, so excellent type 2. This one, I've kind of done a lot of work already. Here's my graph, and it's shaded out all up here, and all over there, and all over there, and all over here. So it's that little white blob that's the feasible region. And I've worked my profit table out. I've drawn it, but I haven't written anything, so there's my table. This is fairly shocking. So that's my vertices and that's my profit, and it's clear that my profit is 4060, which happens to be that point there. And notice how I had a decimal here and I haven't investigated it because it's not the maximum profit, so I don't have to. And then this is the kicker. Investigate what happens when the profit changes to no longer being 15 lots of X, it's something else. And basically, there are two types of excellence type 2 questions. They can ask you, investigate what happens with this profit changing if we keep this point, or investigate what happens to that profit changing if now we have multiple solutions. And the technique is the same on both of them. My new profit is a number, so I'm going to use the hash sign as a number, and that equals px plus 20y. Now, I want to know that in terms of y, so I'm going to rearrange. So I'm going to get y equals minus px over 20 plus my number over 20, and then I'm pretty much going to ignore this last bit because I'm only actually interested in my gradient. So my gradient is minus p over 20. And if I look at my gradients from my two lines up here, so first off my green line, which is that one, if I rearrange that and find that gradient, I'm going to get y equals minus 5x over 10 plus 800 over 10. And if you're not coping with the rearranging, maybe excellence isn't your friend. So gradient is minus 5 over 10. And if I rearrange my second one, I get y equals minus x plus 100. So my gradient, oh dear, something odd's happening there. Gradient is minus 1. Now, if I equate these gradients, so minus p over 20 equals minus 5 over 10, I get the two minuses cancel, and I end up with p equals 520 is 100 divided by 10, so that's 10, and I get p minus p over 20 equals minus 1, so p equals 20. So therefore it's told me that my profit value for p is somewhere between 10 and 20. Oh, I've just committed a cardinal sin, so I'm going to quickly get my eraser and rub out that less than equal to. Now, here's the kicker. If I'm told that I've got to keep the same optimal solution, this optimal solution here, then my values for p could be between 10 and 20. Cannot be equal to 10 or 20, because when p is equal to 10 and 20, then I'm on the line going down there, and I have, that's when p is 20, and when I'm on that line, p is 10, I am on that line, and therefore I have more than one solution because every point along that line or that line is now a solution. So that's a very, very, very quick version of this excellence. It's all about gradients. I personally don't view that either of these excellences are particularly hard conceptually. Mathematically, they're not that tough. It's just you've got to be able to do the work and make sure you don't make some mistakes. Excellence in a nutshell. Good luck.